Okay, so this time we will have the angles included. Okay, so we got the x and the y coordinates. Okay, so this is the trajectory of the motion. All right, so initial velocity. And I'm also going to have the final velocity included here. Okay, so final velocity. Okay. Initial angle. We'll have the final angle. Initial velocity is going to have two components. It's going to have a component along the x direction, and it's going to have a component along the y direction. X is going to denote the range. T is the time for it to travel this distance. And the letter y is going to represent the height. Okay, I messed it up. This is weird. All right, so this is going to represent the height of this motion. Okay, once again, guys, the time it takes for it to travel this far is the same time it's going to take for it to go up and come back down. All right, so it's the same amount of time it's going to take for it to go up and come back down. Okay, so those things are the same. Okay, so let's adjust the formulas, free fall formulas. Okay, so we'll make some adjustments to the formulas. So free fall is the motion on the y direction. Initial velocity times time plus or minus 1/2 gt squared. Final velocity equals initial velocity plus or minus g times t, and the square of the final velocity equals the square of the initial velocity plus or minus g times height. Okay, so projectile motion along the x direction. Okay, life is going to be easier along the x direction, so we are reduced to only these two formulas. Acceleration is going to be 0, so which means that the initial and the final speeds will remain the same. Okay, so we got 5 formulas. 1, 2, 3, 4, and 5. So this is what we will get to use. Okay, the next thing we need to do is we need to express these speeds, initial speeds, in terms of the angles. We could do the same thing for the final speed as well. Okay, because the final speed is also going to have two components. It's going to have a component along the x direction, and it's going to have a component along the y direction. Okay, so it's going to have a component along the x direction, it's going to have a component along the y direction. Okay. All right, so what we need to do is we need to express the initial and the initial speeds in terms of the angles. So that's what we will try to do now. Okay, so we'll add angles into this. Oh my God, this is going to be exciting. Okay, so you can express the initial speed on the y direction. Okay, guys, so here's the initial speed on the y direction in terms of this initial velocity. Okay, so this would be the component of the initial speed. So this is going to be the opposite over the hypotenuse. So this is going to be the same as initial velocity times, it's going to be sine of the angle. Okay, now take a look at this one. Initial component of the initial speed on the x direction. So you're interested in the projection of this on the x direction in essence. Okay, so this is going to be the cosine of the angle of the initial speed. That's it. So let's write this out. Here's your initial speed. And your initial speed is going to have two components. It's going to have an x component. Here's the angle. And notice that it also has a y component. This y component is going to be the same as this. Okay, it's a vector. You can move it around any way you want. It doesn't matter. Okay, notice that it gives you a nice little right angle triangle. So you got your nice little right angle triangle right here. Right angle is right here. All right, so the opposite over the hypotenuse is going to be your sine. So that gives you the y component. Adjacent over the hypotenuse is going to be your cosine. So it gives you that. That's it. Okay, so just remember those.
These are formulas, by the way?
Okay, this is, I wouldn't say these are formulas. These are formulas from physics. This is just trig, or you could call it calculus. It doesn't matter. All right, so this is the y component of the initial velocity. This is the x component of the initial velocity. I want you to notice that the y component and the x components are angle dependent, so they depend on this initial angle. Okay, so that's it. All right, so this is either trig. If that's going to make you feel better, I'll call it trig. If you like the term calculus better, I will say calculus because it's a vector. It's got two components. So it's got a projection along the x direction. So the projection along the x direction is the sine of the angle of this initial speed. And the projection along the y direction is the cosine of the angle for that initial speed. Okay, so that's how we will do this. Okay, so visualize it for you. So let's get out of here. All right, so it's going to be a full projectile motion. X and Y axes. Okay, guys, get used to drawing things out. It's going to help you think better. All right, so what do we know? It's being kicked with an initial velocity of 50 miles per hour. That's your initial velocity. It's 50 miles per hour. At an angle of 35 degrees. That's your angle, 35 degrees. So it says, how much later does it hit the ground? Okay, so the thing that I'm interested in is the time it takes for it to land. Oh my God. All right, so how much later it's going to hit the ground? All right, so T is what we're looking for. We want this in terms of seconds. I want you to remember that the T is also the amount of time for this to go up and then come back down. All right, so that's also the same T. Okay, so it's going to reach its maximum height and it's going to come back down. Okay, so while at it, okay, so I'm not going to show work. Okay, so what's 50 miles per hour in terms of meters per second?
22.31 meters per second.
Okay, so it's 22 point what?
31.
Meters per second. All right, give yourself 5 points. Okay, so well, once we know how to do conversions, you don't have to keep showing me how to do it. So now that you guys know how to do it. Okay, now we got problems. The problem is T is what I'm looking for. Okay, so if you go to the formula sheet, you will notice that these are the 6 formulas that you got. Horizontal motion and free fall. Okay, so obviously these terms will drop out. Okay, so we don't need those. And the last one is useless. Okay, so this is motion along the x direction. That's it. So now I got my formulas. All right, everything looks fine. So T is what I'm trying to figure out. So, now what do we do? Okay, which formulas can we use? This has T in it. This has T in it. This has T in it. Okay, I think the best thing to do is just label everything right now. It's gonna make the communication easier. Okay, so which ones have T in it? Okay, so this one has T in it. And this one has T in it, so is this one. Okay, so which one can I use for this problem? Okay, so you could do a trial and error. Can you use the last one? I'll say no. Why not? I cannot use the last one because I don't know the final speed. Okay, so I don't know what the final speed is on the y direction.
You can use number 2.
All right, and let's try number 3 first. Can I use this one? Okay, I don't want to use that one yet. Number 2, you cannot use number 2 because number 2 doesn't have a T. Acceleration is 0. That term already dropped out. All right, so it's out of the question. Can you use number 1? You don't know the distance either, so that's unknown. So this is no. This is no. How about this one? Can we use this one? This looks very promising. Okay. Except, do you know the total distance along the y direction when it goes up and down? Okay, guys, notice that it starts from here, and then it's going to end at the same point, right? So what is the final height at the end of the motion? This one is going to be 0, so you already know this. And all of a sudden I'm thinking, damn, I can use this. I'm looking at it, I'm already salivating. Okay, so let's use that one. That looks to me like the one which is the most promising. Okay, so number 3 is the one that I decided that we should use. This looks really good. That looks delicious. Okay, let's use that one. All right, so final height, initial speed on the y direction, plus or minus 1/2 gt squared. Okay, guys, what is the final height? What is the final height here?
0.
It's going to be 0. Immediately you go, oh, and all of a sudden you realize that you know something else. What you know is right here, you know that the final height is going to be 0. All right, so which means that this term is going to be 0. Okay, and then what is it that we're trying to solve? We're trying to solve t for this motion. Because remember, the time it takes for it to travel this way is the same as the time for it to go up and down. So it's the amount of time for it to go up and down is the same t. Okay, so now we got an expression that's going to look like this. Oh, initial velocity on the y direction plus and minus 1/2 gt squared is going to be equal to 0. So solve for t. Okay, now we have to make a decision in terms of, yeah, plus and minus. Okay, so which one did we use and why? Okay, so we never discussed this. And on the test, I gave you a little bit of a hint, but this is a good time to make a decision. Okay, so what I want you to do is I want you to take a look at the direction of the initial speed. All right, so take a look at the direction of the initial speed. Take a look at the y component, direction of the y component. Okay, notice that the direction of the y component is going up against gravity, which means that this thing is going to slow down. All right, so gravity is pointing in the downward direction, roughly about 10. And this thing is going to be slowing down. So look at the direction of the speed, initial direction of the speed on the y direction. If it's going up against gravity, it's going to slow down. If that's the case, just use the negative. All right, so because of the simple reason that this is pointing in the upward direction, this is pointing in the upward direction, and gravity is pointing in the downward direction. So which means that gravity is going to actually subtract speed from it. So I'm going to end up using the negative because of it. Each and every single book has an explanation for it. I'm just trying to give it to you in the way, this is the most commonsensical way of doing it. All right, so the rest is straightforward. So what I'm going to do, I don't want to keep showing work. I'm just going to move this across. All right. And then I'm going to switch sides. I don't care, to make it easier. I'm doing too much work here. All right, so get rid of 2. I will get rid of 2. And then I'm going to get rid of g. And then notice that you have a t here. And you have a t squared here. All right, square and the t's will cancel. And I'm kind of done. All right, so the final expression is going to look like this. T is going to be 2 times the speed on the y direction divided by g. Okay. I will stop at this point, check to see everything is kosher. All right. Notice that we have an expression for g, which is here. So I'm good. 2 is a number, but do we know what the initial speed is on the y direction? No, we are given the initial speed. All right, but not the speed on the y direction. Okay, so we have to do a little bit more work. Okay, so I'm gonna, yeah, so I'm gonna bleed into this region. Okay, because after this we're gonna be getting rid of this. Okay, so we got a problem. So the problem is now we have to finish this up. What do we know? We know that the initial speed on the y direction. So here's what we know. We know that the initial speed on the y direction is gonna be the sine of the initial speed, right? All right, so which means that this is going to get substituted into that. And when you do that, it's going to look like this. So it's going to be 2 times the initial speed times the sine of the angle divided by g. And this is the final format. Okay, now you got a number for the initial speed. You got a number for the initial angle. You got a number for g, obviously. All right, so now you just put in the numbers. So you got numbers. Initial speed is going to be 22.31. All right, 22.31. So you have the sine of the angle. What's the angle? Angle is 35 degrees. And your g is roughly about 10. I'm going to make it roughly 10. Okay. Now give me the answer.
I got 2.559.
Okay, let me get a verification. Did somebody else get the same number?
Yeah, I did.
Okay, very good. So both of you guys give yourselves 5 points. That's it. Okay, do you guys notice how much work this was? Okay, number one, being able to pick this equation actually required a little bit of thinking. Okay, it wasn't as easy as, oh, gee, let me just pick a formula and that's solve it. You have to realize that the final, okay, so the letter y represents the final height. This final height is 0, and you have to remember that the amount of time it takes for it to go up and down is the same as this. And eventually, you notice that this is the only one that made sense. And then obviously